Now I would like to present you some more mathematical operation like modulo, negative value from our value, and ABS, so take absolute from our value. So start with the negative, so it creates two's complement. As you probably think that it will change our sign of our number, so if you think in this way, it's correct thinking. We choose integer. Integer needs our word, so we write MW0. Next 3 after it is MW2. We make something like this and download it to our program, to our PLC. And what we have got? We have some strange value here. Maybe it is remains for our previous programs. And we can even see that if we put here the value with the negative sign, so minus, we have got on the right side the same number, but it is on plus side of our digits. If we modify this operand, for example 3, this 3 will be convert to -3. So I think that it is very easy operation. It only create the negative sign of our number or digit. Next, I would like to show you the ABS function. So we create the absolute value. For example, we put it here after our negative sign. We write here exactly MW2, so our result from previous operation, and we put it to MW4. Why 4? Once again, we need for integer 2 bytes, so 2 bytes from second it is fourth. After this change, please once again it download to the PLC, and you will see that the ABS function will create always the absolute from our value here. Now I would like put you some news, not only work on integer values, because if we have some floating point number with dot, so for example 4.3, we cannot write it in integer variable. So please change this our negative sign in our operation of the first block of negation. Please change it to real. We have got real and L real. Difference is that real needs double word because it is on 32 bits, and here it is long real and it needs 64 bits, so 2 times more. But we use for us the real. As you can see, in the input we can put our MW, so some smaller value than real, but on the output it cannot be value which is written only on 16 bits. It must be longer area. So in order to make it correct, please change our first variable. For example MD, I will tell you 12, and here MD 14. It's correct? No, it's not correct, because it is a double word and needs 4 bytes, so it should be 16. If we write 14, of course it will work, but our result will be wrong. When we put these values, we will see that we can put the more precisely our digits with some point sign. As you see, here we have got a representation of the hexa after this change, but please modify our operand and write, for example, 4.56. 4.56, we put negation of it, so it is minus 4.56. So it also works on real, but you have to change our data type of the block, and of course work on some special area. You can, as I told before, you can use some smaller area to input, but on the output must be for our type defined in the block. And the last instruction is modulo. So it is here. It returns reminder of division. So what it will make exactly? We put, for example, for input 1 digit or number, and here second, for example 2 divide by 1. When we it divides, so we have exactly the number of 2, and remains is 0. We will check it. We can also write here some numbers. We have to only put exactly what we would like to make. So we want operate on integer, and we want exactly make 2 by 1. And output, we cannot write the number because it's not area in our PLC. We have to write somewhere it to the PLC. So for example 40, MW40. Or maybe better question for you, I would like not to make so big hole in our not used memory, so I name it hole in the PLC memory, because our last used it is MD16. So the question is which MW I can use in order not to overlap the same area used here. It can be MD16. No, it can't be because it starts from MD16. MD double word 4 bytes, so it will use MD 16, 17, 18, 19. So next 3 not use memory is 20. So we write here MW20. So once again download it to the PLC, load it, and you will have the modulo from our division. 2 by 1 is exactly 2 without any remains. If we make, for example, 3, we want multiply by 2, so it is 1.5, so 1.5 in other way. And we see that it is 3 divided by 2, so it is 2, and 1 it is remains. We also use some like these functions, for example, for decoding systems or for writing some longer numbers for decoding each digit, and we use something like division with the function of modulo. We have also here more functions like increment, decrement, but they are very similar. You can see how it exactly works. Of course, we have also some square root, natural logarithm, and so on. So but these functions are not so often used in the program. Maybe some specific situation, and much more often in SCL language than in ladder language, because in ladder language mathematical functions are much more complicated, and sometimes it is very hard to create some program in the ladder. It's better to use than text language.